Hi, I'm Mozhi.
Hi, I'm Yoshinari.
We're glad to present our paper here.
This paper studies cross-lingual word embeddings and makes two contributions.
Previous work often compares cross-lingual word embeddings using an intrinsic evaluation task called bilingual lexicon induction. We explain what's wrong with this. Motivated by our insight, we then use retrofitting to improve cross-lingual word embeddings on downstream tasks. So Yoshinari, what are cross-lingual word embeddings?
Cross-lingual word embeddings map words from different languages to a shared vector space, such that words with similar meanings are close regardless of the language.
And when do we need these embeddings?
They're useful for cross-lingual transfer learning. For example, if a model uses English-German cross-lingual word embeddings as features, then you can train the model in English and use it in German.
That's very cool. How do I build cross-lingual word embeddings?
Most recent methods use linear projection. We train monolingual word embeddings for each language, and we align them with a linear mapping.
And how do I find the linear mapping?
In this paper, we focus on methods that use a small training dictionary, which is pretty easy to find for most languages. We can train the linear mapping to minimize distances between all translation pairs in the training dictionary.
I see. But a linear mapping is very restrictive, right?
In theory, yes, but the method works pretty well in practice.
How do we know if our cross-lingual word embeddings work well?
Recent work often uses an intrinsic evaluation task called bilingual lexical induction, or in short, BOI. In this task, we first train cross-lingual word embeddings with a training dictionary. We then use the cross-lingual word embeddings to translate a set of test words.
So for example, if the test word is energy, we can translate it into German by looking at its nearest German neighbor in the embedding space, right?
Exactly. And we can compute accuracy by comparing against reference translations.
But in the end, we still want to use cross-lingual word embeddings in downstream tasks. So why do we care about BRI?
Intuitively, good cross-lingual word embeddings should do well on BOI because translation pairs should be close to each other. Therefore, we expect cross-lingual word embeddings with high BOI scores to also perform well in downstream tasks.
Is this true in practice?
Surprisingly, previous work shows that BOI accuracy does not always correlate with accuracy in downstream tasks. I wonder why that might be.
I might know why. You see, BRI accuracy only rewards you for getting the test words right. It doesn't matter what you do on the training set.
So what? That's how the test set works.
But the training dictionary might cover words that are useful in other downstream tasks. For example, if the word good is in the training dictionary, then knowing its translation is useful for multilingual sentiment analysis.
I agree. In fact, some BOI benchmarks use more frequent words for training and infrequent words for testing. So words from the training dictionary are often more important in downstream tasks. This mismatch is also likely to appear in practice because frequent words are more likely to appear in digital dictionaries.
Yes, this also suggests that BRI gives an unfair advantage to linear mappings. While linear mappings can generalize to unseen words, they're not expressive enough to perfectly align all training translation pairs. In other words, they underfit the training dictionary.
I wonder if we can exploit the training dictionary better to help downstream models.
I have a simple idea. We can overfit the training dictionary with a post-processing step.
And how would you do that?
It's easy. We first train a projection-based cross-lingual word embeddings and then retrofit to the training dictionary. Intuitively, retrofitting post-training pairs closer while minimizing deviations from the original embeddings. If you're interested in the math, feel free to pause now and read the slide.
So retrofitting would align all training pairs almost perfectly, right?
Yes, the updated embeddings have 100% training BI accuracy.
Does this overfitting help downstream tasks?
So we evaluate on two cross-lingual transfer tasks, and the updated embeddings often have higher scores. This confirms that fully exploiting the training dictionary is important.
There is one problem though. Now you've broken BOI test accuracy. Why would that happen?
While retrofitting pulls training pairs closer, it may also separate translation pairs outside the training dictionary, so test BI accuracy might drop. In contrast, projection-based cross-lingual word embeddings underfits the training dictionary, but they can generalize to unseen words.
Can we have the best of both worlds?
How about we retrofit to both the training dictionary and the synthetic dictionary induced from the cross-lingual word embeddings? The synthetic dictionary keeps closely aligned word pairs from the original cross-lingual word embeddings, so retrofitting to both dictionaries should help keeping some of the original cross-lingual word embeddings correct translations.
This seems like a more balanced approach.
Yes, adding a synthetic dictionary slightly lowers the training BI accuracy, but increases test BI accuracy.
Does the synthetic dictionary help downstream tasks?
Yes, the downstream models are further improved after adding a synthetic dictionary.
This is great.
To recap, we explained why BI accuracy does not always correlate with downstream task accuracy.
We also show how retrofitting improves cross-lingual word embeddings in downstream tasks.
Thank you for watching.